So there were some questions about plotting. A few people had suggested using Desmos. You can also use Matlab, which we're going to be using a bit later in this course, so might be good to start getting used to it now. So I'm going to try plotting 2.1. So this is section 2.1, number 4. I'm going to try plotting the solution there. Just writing that down so you can see it. I don't want that. I'm also going to use this percent sign, which comments out a line in Matlab, which means that when running the code, it's going to ignore that. So there should be no issues if you include a comment like that. So there's a few different ways to plot equations, but this is kind of the easiest one that I know of. I will also write down what the equation that we're plotting looks like here. So I'm gonna do another comment line, and we're plotting y of t equals 2 times t minus 2, minus 2 times, 2 minus c times the exponential function to the negative t. So that's what we're going to be plotting. And then it says for a bunch of different c values. C equals -3, -2, ... all the way. So -1, 0, 1, 2, all the way up to 3. So first, what we want to do is we want to tell our function. Well, first I'm going to pick one of the c values, actually. I'm going to define one of the c values. It doesn't matter which one, but I'm going to start with 0 for now, just because that's probably the easiest one. And we can look at the plot and make sure the figure makes sense. Then I'm going to define what my t interval is. This is going to take some playing around with on the different plots, because I mean, it's not going to make sense if we go from 50 to 100, but maybe 0 to 10 is okay. Maybe -10 to 10 is okay. Let's see what happens if I do, I don't know, let's start with -5 to 5. And the way that we do that is we say that t is going to start at -5, and then we're going to set some sort of step size. So where do we want our next t to be? I usually pick a very small step size because I want my line to be very smooth. So I'm going to say 1 over 100. So every 1 over 100th, it's going to, do a new calculation. And then we're going to go, let's say, to +5. So that's the range that I'm inputting into my plot. Now we need to actually define what our equation is going to be. For this one, as I wrote up above, it's 2 times t minus 2, and then c, plus c, big C. Gotta make sure it's the same or else the computer won't know what I'm talking about. And then the way to do the exponential function in Matlab is exp parentheses -t close parentheses, and then I'm going to do a semicolon here. You don't need a semicolon after each line, but basically it just suppresses the output. If I did not put that here, it will actually plot all the calculations for every step in this command window, which we don't need, but sometimes if you're trying to check calculations to make sure things make sense, it's good to do that. Okay, so now I'm going to actually do the plotting, which I'm going to use the line function. There's a few other sorts of functions. I'm going to say that my independent variable is t and my dependent variable is y. And now I have everything here, and I'm going to run section and show you the figure that I got. So I got a line here. Now, does this make any sense? Let's take a look at our equation. So I'm picking c equals 0. So yeah, that makes sense because we don't have to worry about this exponential, and we just have t times 2 minus, 2 times t minus 2, which is the equation for a line. Great. Now we want to see what happens when we have a few more other c values here. It's nice to put them on the same plot, and so you can compare them. However, if I just change this to 1 and run section again, it's going to change. It's typically going to change here. The reason why it didn't is because I think there's a command that's still happening in here. But if we want to plot, I'm going to close this for a second. Say we wanted to plot multiple lines, multiple curves in the same plot, we can use this command called hold on. So it's turning the hold command on so that it's holding the previous figure and then plotting the new one on top of that. So we can now start at, say, -3. I'm going to now run this and show you the figure. So here we have what it looks like for -3. And then I'm going to now change this to -2, run this again, and we see that it's just plotted right on top. That's great. Let's do -1. Here, I'm just doing this all like one by one, but if you're more familiar with coding, one thing you could do is you could make some sort of for loop function where you're looping over the c values. So, and the function will do it all automatically. So here, now we can see what this looks like for -3 to 3. And this is also what I meant and what the problem means by, let's see, experiment with different intervals for t until you have a plot that shows what you consider the most important behavior of the family. So we see how for different c's, this actually ends up, they end up being kind of apart from each other and end up converging onto one sort of line. Let's say I didn't pick -5 to 5. I was actually pretty lucky. I didn't plot this beforehand. So you're kind of seeing all my mistakes and stuff right away. Say I didn't choose -5 to 5. Let's say originally I was like, I don't know, maybe 1 to 5. I'm going to change my limits here so you can see what happens if we only saw the 1 to 5 right, like input domain, I guess, is the proper mathematical term, which I should be using. So while we can run a full code up here, I can also do commands line by line in the command window. So that's what I'm going to do here so I don't have to keep running the full simulation. Okay, so actually we can see that there is some sort of split here, but possibly, like I said before, if I did 100 to 200, it could be different. If I have a different range on my y values, we could maybe not see the spread as much. But this is how you could plot multiple lines. If you want to save it now, you can go to save, and here untitled.figure. You probably, for uploading purposes, don't want to use figure. If you go to format, you can change it. PNG is okay, but PDF is probably the best. So you can do, let's say for this one, I'm going to say 2.1 number 4, because that's the problem, .pdf. And then when I save it, I'll be able to access that plot somewhere else. Now, quickly, I'm going to show what we could do if we wanted a loop, so we didn't have to do them one by one, because I think one of the problems, let me check. If I remember correctly from last semester, I think one of the problems either here or later has a lot of different C values that you want to plot over. Okay, so we want what's called a for loop in Matlab. need to quickly, yeah. So let's say 4, and then I'm going to say what my variable is. In this case, I'm going to be looping over C. So I'm going to say C equals, and let's say I'm going to do, let's say minus 10 to 10. Then we have to make sure that the code knows where the loop actually is, what we're looping over, and where it ends. So now this is telling us it's going to loop. I'm going to clear everything, and I'm going to close this so there shouldn't be any more figures. Let's say, okay, let's try to run this right now. Awesome. Okay, so this is the plot that just came up. You can see that it really quickly plotted all of them for me. The plot just popped up on my other screen, and then I just dragged it over so you can see it. But I didn't have to do them one by one, and it did it really nicely. So that's it for plotting in Matlab, and I guess showing you kind of some for loop action. But if there's any other questions, let me know. I'll probably be making some other nice videos for later in the semester when Matlab comes up. And here's Millie who says, coding is fun and have a nice weekend.